Hello all, I am Rajeshan, working as an assistant professor in the Department of Electronics and Communication Engineering, Maharaja Institute of Technology, Mysore. The forthcoming sessions we will be seeing with respect to the course, which is Wireless Cellular and LTE 4G Broadband with the course code of 17 ECE 81. When we just see the evolutions of the mobile phones, we can see there are different generations with respect to the evolutions, starting from 1G, 2G, 3G and 4G. And in today's technology, what we do have 4G. All the mobile phones are equipped with the 4G generations. That is what we would be studying with respect to the particular course. The LTE stands for the long term evolution. The course outcomes of the particular subject, as you can see, the CO1, it represents the system architecture and the functional standard specified in LTE 4G. So, exclusively we will be dealing with respect to the architecture of the 4G LTE, and we will try to understand what are the different equipments or what are the different components that are there in terms of the architecture of the 4G LTE. The next, CO2 deals with the signaling process of how a signal is moving from the transmitter to the receiver, and that is what it says. Apply the concepts of LTE, radio interface protocols or the standards for the resource management, mobility management and intercell interference coordination. So, the signals are moving from one particular sender to the receiver, how the signals are specified in terms of the standard format, which is called as protocols. So, that is with respect to the CO2. And next, CO3 deals with the analysis or analyze the multi-carrier technique and multiple antenna transmission and reception techniques as applied to the LTE. So, we would be dealing with respect to how the signals again would be moving with respect to the multi-carrier techniques and with respect to the multiple antenna transmission techniques. We will be analyzing with respect to the performance. Next, last, which is the CO4, it deals with the analysis or the analyze the role of LTE radio interface protocols and EPS. It is an evolved packet service data convergence protocol to set up, reconfigure, release data and voice from the users. Again, the protocols are nothing but the standards and how the signals are moving from one particular location to another particular location. So, that would mean that from the sender to the particular receiver. So, these are the course outcomes of the subject, which is wireless cellular and LTE 4G broadband, and we will see how the subject is split up. It is split up into 5 modules. So, again the module 1, as you can see, it deals with respect to the LTE features, which is nothing but the architecture of the particular LTE. In terms of the architecture, what are the different components that are there in the LTE. It deals with respect to the LTE features and the advantages of why we are defining an LTE rather than with respect to the previous generations, and wireless fundamentals. So, basically how the signal would be moving from one particular location to another particular location, that is from the sender to the transmitter. So, that would be dealt with respect to the module 1, which is LTE features and wireless fundamentals. And next, module 2 deals with a specific technology, which is an orthogonal frequency division multiplexing, and it deals with respect to the concepts of OFDM, the basics and the concepts of OFDM. And the module 3 deals with the channel structure of LTE. So, again the signals are taken through the channels. So, different channels are defined. So, we will be studying with respect to the channels with respect to the LTE. Module 4 with respect to the the channels or the signals that is moving. So either it is an uplink or it is a downlink. We will be studying how the signals are moving from one particular component to another particular component. So which is the uplink channel transport processing. And module 5 deals with the radio resource management and the mobility management. Again, how if a particular subscriber who is taking a mobile phone is moving from one location to another location, how the signals are defined in terms of the communication process, which is the mobility management. So these are the things we would be defining in terms of the course, which is wireless, cellular and LTE 4G broadband. So before dealing with respect to the module 1, we will see some of the basics how a typical cellular component is defined or the architecture of the typical cellular component. As we have seen regarding to the course outcomes and what is the syllabus that is there with respect to the course, which is split into the 5 modules, we will see the basics of the wireless systems or the wireless communications. When we take the wireless communications or basically the telecommunications, a specific area is represented with respect to the cells. An area is represented with respect to the cells, and the cells are divided into hexagon. If you take a particular area and that particular area is divided in the form of an hexagon. So this is an hexagon of a representation where the cell is defined. We will see the different or the typical cellular architecture, what we have seen regarding to the generations of the 1G, 2G or 3G or 4G. Specifically, we will see a 2G generations of a typical cellular component. Typical cellular component, and again we use mobile phones, and the mobile phones are, or the cell phones, what we do call, it is called as mobile station. In short, it is called as MS, or the mobile station. It is also called as subscriber device. The mobile station or the subscriber device, it is connected to the tower, what we do call, and in the terms of the technical representation, it is called as radio base station. Again, we have a defined signal which is moving from the mobile to, let us say, an antenna. Antenna is a tower, and in that particular antenna, what we do have a radio base station. In short, it is called as RBS. RBS, or it is defined as radio base station. When we take this particular example, as we have told, an area is divided into cells and the cells are represented in terms of an hexagon. If you take this as cell 1, and we will write an another cell which is represented in terms of an hexagon, and in a cell we do have a tower, or it is called as a radio base station. It is called as radio base station, and this particular radio base station is again connected to another component which is called as BSC. BSC stands for base station controller. Suppose if we want to monitor the radio base stations in the particular cell, we do have a component which is called as BSC, a base station controller, which monitors the radio base station. If there is a faulty in a particular cell of radio base station, so to correct the faultiness of a particular cell of the radio base station, a base station controller is used. So what is the work of the base station controller? It is used to monitor the numerous radio base stations. So it is monitoring the numerous radio base stations. And in this component of BSC, we do have TRC, which is called as a transcoder controller, and this transcoder controller performs the operation of rate adaptation. When a signal which is converting into an analog to a digital signal, or a digital to an analog signal, numerous rate adaptations have to be performed such that a signal is moving from the sender to the receiver, and it is performed by the TRC. Again, this particular BSC and the TRC can be a standalone component. Standalone means you do have a single component which is represented by the base station controller, and we do have a single component which is represented by the transcoder controller, and also it is an integration of the base station controller with respect to the transcoder controller. So this whole system of what we do call it as, we do have an antenna, we do have a radio base station, what we do call it as a tower, and again what we have told is to monitor the numerous radio base stations, we do have the base station controller, and to perform the rate adaptations of the signals, what we do have, it is the TRC. In whole, we do call it as the base, it is base station subsystem, or in short what we do call it as BSS. RBS can be represented, radio base station can be represented as an RBS, base station can be represented as the BSC, or the transcoder controller, what we have told, it is represented as the TRC. So this is the components, and to this particular base station subsystem, we do have a fixed switching system, which is nothing but the servers or the databases or the registers. We do have the numerous servers or the databases or the register to monitor the location of the mobile phone or the mobile station, and to define the signaling connections of the particular mobile station when a call is made or when we do receive the particular call. So this base station subsystem is again connected to a fixed switching system which has the servers or which has the databases. The first server or the database, what we do call it as an MSC. MSC as an MSC. MSC stands for a mobile switching center. What we do call it, it is the heart of the telecommunication systems, and it monitors the routing or the setup of the calls from the sender to the receiver, which is an MSC. And to this particular MSC, we do have another register which is called as the visitor location register. Suppose if some of the subscriber, if the subscriber is moving from one particular location to another particular location, or one particular area to another particular area, then the location of the subscriber has to be updated with the current area where he resides in. And for that particular location updation, what we do have a register which is called as visitor location register, or it is called as VLR. Which is called as a visitor location register. Next, to this particular MSC or VLR, we do have a database or a register which is called as the HLR. It is called as HLR. HLR stands for Home Location Register. HLR stands for Home Location Register. Suppose if a subscriber wants to take or wants to make a new connection, and he takes a SIM card for his mobile phone or for his mobile station, and all the details that is defined of his address and the identification is stored in the register, which is called as the Home Location Register, or it is the HLR. And to this MSC, we do have another register which is called as EIR. EIR stands for the Equipment Identity Register. What does this Equipment Identity Register means? It provides a uniqueness between one mobile phone with respect to the another mobile phone. Suppose let us take an example. You do have a specific mobile phone which is manufactured at a lot. That would mean that around 100 same mobile phones have been manufactured, and we need to provide an uniqueness between one mobile phone to another mobile phone, and that uniqueness is stored with a particular register or a database which is called as an Equipment Identity Register. So, to provide the uniqueness between one mobile phone to another mobile phone, we have a defined set of serial, and this particular defined set of serial is called as an IMEI number, which is called as an International Mobile Equipment Identity Number, and these particular numbers are registered or it is stored with respect to the Equipment Identity Register. EIR, which is Equipment Identity Register. Again, we do have a database which is called as an FNR. FNR stands for the Flexible Number Register, FNR. Flexible number register. So, in order to perform the MNP, the mobile number portability, so where you can keep that particular number, but you can just change the service provider, and it is done with respect to the particular register which is called as an FNR. And for the gateway, we do have a database or a register which is called as Gateway Mobile Switching Center, which acts as a gateway for the mobile switching centers. And again, if you take the operation of the mobile phone, there are two operations for the particular mobile phones. Either it is a voice or it is a data. and to define the data we do have an interface mechanism, and that interface what we do call it as the IWF, which is interworking function, and this IWF is connected to PDN, which stands for Public Data Network, and we do have a circuit switch which is defined and which is called as PSTN. PSTN stands for a public switch telephone network. So these are the different components or the setup that would be there in terms of a typical wireless cellular system, where we can see a mobile station is connected to a base station subsystem, and the base station subsystem is connected to the what we do call it as a fixed switching system. And in terms of the fixed switching system, we do have the registers or the database where there is an updation of where the mobile station is defined. Again, what we have told is that if you take the telecommunication system, the area is defined or the area is designed into the cells, and each cell is represented by a particular hexagon. And when you see the process, what we have told is that in a cell we do have radio base stations, and these particular radio base stations are controlled by the base station controllers. In order to perform the rate adaptation with respect to the signals, what we do have, it is the transcoder controller, and in terms of the updation of the signal, what we do have, it is the servers or the databases or the registers. What we have called it as an MSC, which is called as the mobile switching center, so which is the heart of the telecommunication systems, where it defines the setup and the routing of the calls to and from the particular sender and the receiver. And next, what we have told, which is called as a visitor location register. So a temporary updation of the particular location is done by the visitor location register. Next, HLR, which is called as home location register. When a particular subscriber makes a contract with the service provider, so where the address or the information that is defined is stored in the particular register, which is called as home location register. And all the unique numbers of the mobile phones are stored in a particular register, which is called as equipment identity register. FNR stands for the flexible number register, where you can perform the MNP, which is called as a mobile number portability. Next, GMSC, which is a gateway of the mobile switching center. And next, for the data of representation, we do have an interface, which is an interworking function with respect to the public data network. And the circuit switch connection, what we do have PSTN, which is called as public switch telephone network. Thank you.